Hello everyone and welcome to the CSE116 Task 1 overview. In this overview, we're going to be going over classes and objects, and also testing. And we're going to see how this relates to your programming tasks and what the matter is with all this stuff overall. So anyways, let's get into the slides here. Yeah, so classes and objects. Now, you guys have been learning about this stuff in all your lectures, which I'm sure you're all going to. So, as you guys have heard, classes are blueprints for creating objects. And objects are just instances of classes. So whenever someone says like, oh yeah, an object is an instance of a class, it just means like it's a created version of the class blueprint. And that's going to be stored in memory. So whenever you guys see the new keyword, you could immediately think we're creating a new object of whatever class the new keyword is adjacent to. Now, if that sounds a little confusing, I'm just talking about this stuff right now. We're going to look at some like actual object creation and examples in a bit. So we'll talk more about that. Oh yeah, and just a reminder, it is absolutely not this kind of class. That's a big confusion we get all the time. It's not that kind of class. All right. Oh, man. Yeah, so testing. Yeah, this is a tough subject for some people. So, testing. Yeah, this is the first task where you guys are actually going to have to write your own tests. So, hey, I understand. Testing, it's a big deal. And some of you might not want to do it. And, hey, listen, I will tell you firsthand, I understand you. But I'll also tell you that testing is really a great tool, and once you get a little more familiar with it, you're going to start to really value how much time testing could actually save you in real development. So we're going to start writing some tests. We're going to go over a bit of how to do that, and hey, if you're stressed about it, I understand. Like, this is a big project that you're going to be just like trying to test into, and I see how that will probably be overwhelming for you. And if it is, don't worry about it. We're going to go over some stuff, and it's actually way less overwhelming than you might think, because what we're having you test is really just a very small piece of the whole game engine files. Like, you don't even have to look at most of the stuff unless you want to. If you want to, I encourage it, but if not, it's totally fine. And yeah, just second reminder here, it's not this kind of test, okay? It's, again, big confusion. It's not that kind of test. It's a little similar in some ways, but it's a completely different kind of test. All right, so with that being said, let's go into the handout. All right, so we are in the handout now. So always the first thing that you guys are going to do is, you're going to read this overview thing and then go to the problem set. Now, you guys know how to clone the repository now, so I'm not going to go over that. You guys have had to do that for your task 0 and your coding quizzes stuff, so I'm not going to go over that again. But the problem set. Now, here's the thing about the problem set. The problem set is a much condensed version of what you're going to be doing in your game features LO part, but it has the same conceptual material. So, if anything, like, if you find yourself struggling with the problem set and you're like, wow, I'm really struggling with this problem set, I'm not going to be able to do the game features LO, don't necessarily think that, because the problem set usually will have like very similar adjacent, like our goal with the problem set is to make it so you guys have the core material learned so that you could tackle the LO for the game features portion. So don't worry too much if you're struggling on the problem set before you get to the game features part. That's totally fine. Now, again, with the problem set, in these videos, I'm usually not going to go over too much problem set specific stuff, because like I said, that material is pretty adjacent to what you're actually going to use in your game feature stuff, and usually this is where people are going to struggle the most when it gets to the game features, because you're going to be navigating this bigger project and you're still going to be dealing with classes, objects, testing. So I'm going to start going over the learning objective portion of the game features, but you could extract information from that and apply it right into the problem set. So, and we might talk a little bit about it, but right now we're just going to start with the game features. Again, like this says, you should always read the overview and everything. And yeah, so everything you build here is going to be a continuous addition from the rest of the tasks. So yeah, this task is going to build on top of task 0 stuff, and it's going to continue being like that for the rest of the semester, so you don't need to clone a new repo. You're going to use the one that you use for task 0. This is a very important part here, especially if you're already like really stressed about the bulk of the engine. For the learning objective portion, you're only going to be writing code in these files here. And like I said in the previous task video, you could navigate here manually, or you could just use the shift trick. And if you don't remember that, I'll show you again. Yeah, so once you get into your project, you will press shift pretty fast, like right next to each other. And then you're going to type in whatever file you're looking for. Oh, whoops. So that's going to be, in this task, physics engine while test task 1. So just to show that off real quick. Shift, and then I'm going to type in wall because I don't see that there. Boom, there it is. Just hit enter, and I'm in the wall class. Perfect, and gets me right to where I need to be. I don't need to go through all of these files, but you could find it by going through the files, and that would be totally fine. So keep that in mind. It's a very useful trick, especially if you already are pretty overwhelmed with how many files are in this project. And yeah, so a reminder here, you might not have the test task 1 class in your app.test package, because this was a thing about we had to reclone the repo or whatever. But if you didn't do that, it should still be fine. You just should download this and put it right into your project because it is pretty important for you guys. So as you can see here, I don't have it. I just have the task 0 stuff. So I would just go over here and find this file here. And now, once you find this file, you just have to press this download button up at the top, download raw file. Click that. All right, downloaded it. And then, if I navigate back over to my project, there's a few different ways you could do this. One way is if you right-click the file that you want to put it in and go to Open In, and then Explorer. This is Windows, it might be a little different on Mac, but if you open it in your Explorer, then you could go to your downloads and drag it right in. So I'll do that as well. Okay, and once you are in your downloads, you just take the test task 1 and move it to your tests. And perfect. Now, boom, it's right here, and you have everything you need. So that's just a reminder for that. And also, I'm going to just bring up this point. I know we're not talking about tests yet, but when you get to writing tests, and we'll talk a little bit more about it later, but I'm just going to mention it now. When you get to tests, you should really look at these example tests that are given to you. Not even like just to like find exactly what it's doing and like copy it or whatever, but you can copy some stuff from them if you find it useful for whatever reason. But when you're writing your own tests, if you see the kind of workflow that these given tests work in, it's very useful when making your own. So like getting used to how these assertions are working, why we have so many here, and like what they're actually doing differently. It's they're very useful to analyze some of these if you're confused. So keep that in mind. It's, you know, of course you could just run these and never look at them, but you absolutely should look at them and try to understand how they work. It will help you a lot in the long run. Okay. So, as we were saying, we are going to be implementing a bunch of features for this task, and now that we have all the things set up, oh, yeah, so we actually need one more thing, which is in the apps.test package, also create a new class called testutils. So I'll just do that just so I have everything set up correctly. So apps, our app.tests, create this, it's called testutils. Whoops, create new class, testutils. Okay, great. If you see this pop up, you could hit add or ignore it. It doesn't really matter because we're not using GitHub anymore. Okay, now we're going to get into the actual bulk of this task, which is these methods here, which are update object, get overlap, detect collision, collide, you know, all this stuff. So first things first, before you even do anything in this, like before you even write any real code here, I'm going to give you guys a recommendation, which is go to your project and navigate to the configuration file. you could either just click there because it's usually right at the like at the bottom over here, or shift configuration. All right, and I'm there. Now your guys' game might be Minesweeper if you did the AO, or it might be Snake or something now, but whatever it is, if you run it, you should get that game. Yeah, so it's Minesweeper, yay. So if it's not Minesweeper though, you're gonna want to change it. Like, this is not required or anything right now, but I'm gonna recommend this because you're gonna be able to see your work basically. I'm gonna recommend to change it to sample game. Just type sample game, and if you're wondering where I'm getting this from, you could actually figure that out. If you shift and go to game factory, you could see all the different games that are in here. So each of these games will have a different type of game, as you can see. So, you know, just a little parallel to before, you see whenever you see this new keyword, you're creating a new object. So that means this Minesweeper game, there's a class named Minesweeper game, and we're making a new object of it. That's just something that you guys should get used to seeing. Like, okay, oh, there's a new keyword, we're making a new object. Just keep that in mind, because it'll let you get used to this stuff quick. So, but anyways, that's not a big deal. The reason I recommend to change it to sample game is because when we play, we're gonna see this. Okay, now of course that's a little loud, but we just have our guy here, and we can't move him at all, and it's pretty lame, honestly. This is no game, so we gotta make it a game. So that's what this task is kind of about. The first thing you make, update object, that's gonna let that guy move. So we have to complete the given update object method. You have to use respective getters and setters to achieve this functionality, you know, all that. So we're dealing with classes and objects here. So if we go over to our update object, you can even type the name of a method and it'll bring you there. That's how nice this feature is with shift. So update object, boom, I'm here. And it's in Physics Engine. So, and you'd be able to say, also just go to Physics Engine class, as it says here, and then find the update object method. But so as we can see, we're given a double and a dynamic game object, which it's funny that this is just called like object, but this is actually an object. Like what we were talking about earlier, it's actually an object. It doesn't have to be called that variable object. But when you press dot next to anything that's an object, it'll bring up all the methods that exist inside this object. So all of these methods are available to us, and yeah, it's a lot, trust me, I know. But like we said, it's a lot less than you guys might think. We say that the only three that you might actually need to use here are get velocity, get location, and set location. Now, if you guys have done the problem set part, you might start to notice some similarities here between a vector 2D and a location. So if we scroll back up here, in the problem set, you had to create a class that represents a two-dimensional point in space. Okay, and it's the location of a shape. Now, again, so in the previous task video, we talked a little bit about vectors and what these things actually are, but it's kind of the same concept as location almost. So I'll show you guys what I mean here, and you might start thinking of some parallels that you see here. Okay, so this is a little grid that I have set up here, and we see this point in the middle. This is our origin point, right, of a grid. Now this point, I would think everybody here could tell me that this is at point 0, 0. This is a vector. In our basic understanding of the game engine right now, this is kind of a vector, okay? Now, if I were to get rid of this, and if I were to make another point over here, this is, let's say this is 1, 1, okay? Which again, most of you guys could probably say that if I labeled these, axis stuff. And so that's 1, 1. Now, here's the thing about vectors. If we had a point here, technically, our vector is like this. It's not pointed at all, but you can kind of think of it as an arrow pointing to that point. So even though we have this point here labeled as 1, 1, it's technically like this. Like we're going this far on the x and this far on the y from our origin So since it's from the origin, that's why we label it kind of like this arrow here. But the only reason I bring that up is because that's going to be useful for our velocity in this update object method. Now, similarly to location here, like this just represents our location. But if we had a vector that was like, let's say, you know, our origin point was right here. But so this vector is 1, 0, because we're going 1 this way. And, you know, like if this is our axis, we're going 1 to the right and 0 up and everything. So because we're facing this way, like our vector is pointing this way, this is the direction of our velocity. So so velocity is also stored in a vector. So it's going to be very useful to kind of think of this as a literal direction and how we're going to move our person with that velocity. So as we can see here, we have, okay, Microsoft, we have a few different methods that will all be very useful to us. Now, I'm going to show you guys what this is going to look like once you have it done. All right, so once you guys actually have update object completed, you're going to see this. So you're going to be able to move your guy around, and it's not going to be able to collide with anything. So you're kind of just like some entity that's moving around this place. You can't even get hurt or anything because we don't have collision set up, and that's what we're going to do later. But I just want to show you guys what it's going to look like so you have something to compare yours to, basically. But yeah, so that's how it's going to look like. And just to be a little more clear here, okay? Because vectors, I get if they're a little confusing, and like there's not too much here to figure out what to do based on everything. Okay, so let's say we have our player or whatever, and they're at this point, okay? You know, a player, like right now, let's just think of a player as a location, okay? That's basically all we care about anyways. So our player's location at this point is, let's say it's just 0, 0. It doesn't really matter, but it's 0, 0 right now. Okay, now whenever we press W, A, S, or D, or the arrow keys on our keyboard, we're physically changing the velocity. Now this is done for you, like this happens already. So the player's velocity changes based on what key you're pressing in the keyboard. So let's say this is our position, and it's a vector 2D. So I'm just gonna say like I'm also gonna call it location, and you guys might know why I'm doing that. You know, think about your problem set. So I'm going to call this location. It's a vector 2D, but it's just a location, okay? Now, this vector, let's say right now we're pressing the right arrow key, okay? So right now I'm pressing the right arrow key. Oh, all right. My velocity is now 1, 0 because I'm trying to move to the right. So this is done for me. Velocity is this right now. Okay. So, in a world where there's no velocity, right? So here's what I'm going to do. Position is going to be labeled with black, and I'll do velocity in like this blue color here. So 1, 0. Okay, and since the velocity is 1, 0, I want the velocity vector looks like this, okay? And this is of length 1. Okay? Now, so that means that like, okay, like we can visually see this now. If our velocity is 1 in this direction, I want to end up right here. This is where my new position should be. But there's a bit of a catch. It's not just adding the velocity to the position, because we have another variable that we have to consider, which is, I'll label this I guess in this dark red, which is this thing called dt. Also known as delta time, or you guys could just think of it as time, okay? So basically, this just means the amount of time that's passed in the current frame of the game. And you guys don't even need to understand this too much. All you need to know is that the only time that's passed is delta time. And delta time might not always be 1, which that's a big deal. So if delta time was 1, okay, if it was, then we would actually move this distance. And the reason is we want to move by our velocity by the amount of time that's passed. Okay? So if the frame took 1 second to compute, then I want to move how much I would move in 1 second, which is velocity times delta time. So it would be the x direction times 1, which this happens to just be 1. So we would actually move this far if delta time was 1, okay? Easy example, great. But in reality, computers are way faster than that. Computers are not going to move, or is not going to take 1 second for delta time. So each frame is not going to take 1 whole second to compute. So in reality, delta time might be something like, I don't know, 0.02. Let's just say that, for example, right? Or no, I'll do like 0.05. No. I'll do 0.1. Okay, sorry, a little indecisive there. All right, so let's say it was 0.1. Well, now it gets a little more complicated because now we're not supposed to be over here. We're supposed to do 1 times 0.1. So we're supposed to move 1/10 of this distance. So while it looks like we were supposed to be over there, we actually should be like all the way over here. Quite a jump from what we talked about before. So you might think, like, how are we ever going to move if we're moving in these low increments? Well, you got to remember, we are calling this method every single frame. Update object is happening every single frame. So we're going to be doing a lot of these little movements in like a second, which is going to end up being what we would expect from our velocity. Now, this was an example where velocity was just 1, 0. But if velocity was different, like maybe the velocity was like 1, -1 or something like that. So remember, it might be a little confusing, but in our game, velocity is in the y direction. If we go a negative velocity, means we're going up in our game, because our grid starts here at 0, 0 and goes all the way down to like, whatever. So yeah, so for the sake of this example, so it doesn't collide with this, I'm going to make the velocity 1, 1, which would just mean that our vector would change a little bit. Our velocity vector would then look like this, okay? Which, again, this is the same thing, like this is the velocity thing here. Like, I am drawing this from our origin, which our origin right now is just our location, okay? So we want to move here, but we want to move here times delta time. So if delta time was 0.1, we actually would only want to move this far, basically. Only 1/10 of this distance. And remember, we get that distance by taking our velocity and multiplying it by delta time. So take what you can out of this description of movement. And know that velocity could be, any of these vectors. Technically, like, it's not going to be something like crazy, but velocity could be anything. Like, for the sake of your understanding, velocity could be any vector that fits within these. It could even be like -1, -1, which would be like this. And whatever that vector is, you have to multiply it by delta time to be able to get where you should actually move in that frame. And now when I say actually move, I mean that the location from before has to get updated to this new location after you calculate it. So again, like I said, the new location for this example would actually be like right here, which maybe this is 0.1, 0.1, because that's 1, 1 times 0.1, right? So that's where we should move. So we have to make sure we update our old location to this new location when it's all said and done. So, and this is a whole big deal with classes and objects, okay? So if we get the location, if we called get location from the dynamic game object passed in this method here, so for example right here, so object.getLocation, right? This returns to me a vector 2D, right? So we have a vector 2D, and we'll call it location, and we'll assign that to this. Now, location is physically the object of this dynamic game object's location, like, meaning that if I did location.setX, it's some number, right? Some double, then that object will actually get its location set to this value, or at least its X position. Now, keep in mind that for some reasons, at some times, we might want to not change the original object's location, and if we wanted to do that, we could just call copy. Okay, so if we copied this location, now if I did location.setX to some number, we're not going to actually change this object's location. We're going to change our copy's location. But that's just to let you guys know that that exists. You might or might not want to use the copy for this method here, but you absolutely will need to remember that there's a getX, getY method. There's also a setX and setY, and those are going to be very useful. Also, vector 2D, velocity, and that's going to be equal to object.getVelocity. I'm not actually writing your method here, but I'm just showing you what you could do to get data that you might need. And remember, these are all classes and objects. Velocity is a vector 2D object. Like, this is an object of the vector 2D class. And if you guys are ever curious about the vector 2D class, you could hold control and click on the class and read it if you wanted to. It's not required, but you know, maybe it clears up some confusion you might have. There's a lot of useful methods in here. This is data that you're going to need. Like, if before velocity was 1, you know, we could get x and whatever, and that would get us this x velocity right here from our example. And we also have dt, delta time, available to us that's passed in our method. So we have all these things available to us. It's going to be very useful for writing your method, and like I showed you before, how it looks when it's done, it's very great. So I'll show you one more time. Yeah, so this is the game. It's, you know, this is how it's going to look when you get that whole thing set up, and that's the exact example I just presented. So yeah, now let's talk about some of these methods here. I'll also show you guys how these look when they're done, but we're going to go over these slightly differently than we went over the update object. Okay, so I've been thinking of different ways of how to explain some of the math stuff that we have to do for the get overlap method. So first of all, I'll say right now that the hardest part of this task is going to be the get overlap method. Once you have that done, the rest is fairly downhill from there. So the tech collision and collide with dynamic object, both of those get wildly easier after you complete get overlap. So we're going to spend a lot of time talking about get overlap. Now before we do that, I'm going to show you guys what the actual completed get overlap, detect collision, and collide, once all of those methods are done, here's what your game should look like. Okay. So this is the game, and I cannot move through these walls anymore. Okay. As you can see, like I'm trying to, believe me, and I cannot move through these walls. Also, when I go down here, hey, if you're reading this, that means you got collision working. Awesome. So now, like, this is feeling a lot more like a game, and furthermore, if we were to collide with these guys, they'll start hitting us and we die. So it's a real game now, technically. And so this is awesome, and we want to get to here. So how do we do this? Now let's look at the doc. So I've been told there might be a few changes to the wording to make this a little more clear, but we're going to describe this in a way where we're going to be able to talk about it no matter what. Okay, so we have to complete the given get overlap method. Now, as we can see with this picture here, we want to return a double, so I'm reading right from the doc here, representing the minimum overlapping distance of the two objects. So, of the two hitbox objects. So a lot of you guys are probably familiar. If you've played games, you know what hitboxes are. Like, even like competitive games, like, oh come on, I should have hit him, when the hitbox is like actually a little smaller than the model or whatever. So you might have heard of hitboxes. It's basically just this, it's a box around the actual sprite or model of the object that will deal with the collision logic. And engines and games do this because it simplifies things. Like, as you can see, this rock shape is like pretty like dynamic, and it's a lot easier if we just calculate the collisions with the box. So we do it like that. Now the get overlap method, what it's really saying is it's trying to get the distance, the smallest distance it needs to leave the overlap. Okay? Think about that for a second. So, as this sentence here says, we would return 0.25 if the x overlap is 0.25 and the y is 0.5, we would want to return 0.25 because it's smaller in the x, and we'd want to get out the smallest way possible. Okay? Now, the reason why I'm trying to word it so explicitly like that is because of an edge case that I found that we should look at really quick. Here is a special case where we have a hitbox in the middle that is completely engulfed by the second hitbox. Now, in this scenario, if you were just thinking like that we're returning the overlap area, some of you might think that we want to return 0.5 because that's the smallest overlap distance between these two hitboxes, right? So of course, like, you guys might have not had time to just read all of these points here, but the width of this is 0.5. So it goes on 2 on the x, and then 2.5 on its second x point. So the width is 0.5. And the height is also 0.5. So that's the smallest overlap between these two hitboxes. But that's not actually what we want to return. We want to return the smallest distance to get this hitbox out of here. So that's going to actually be, if each of these units is 0.25, it would actually be 1.5 because we'd want this hitbox to move to this point right here. That's the smallest distance that it can move to get out of this bigger hitbox. Now, a lot of you guys are probably like, whoa, how am I supposed to calculate this? It's a pretty like daunting thing. And I'll be honest, it's not trivial. We have to look at this problem and boil it down into smaller problems so that we could solve it. And this is a good exercise. Just, this is math right now, basically, but translating it into programming, like, this is a skill that you guys are going to use all throughout CS. So let's take a look at this. I drew up some examples here so that we could look at this a little better. Now, first thing that I'll say is that this method becomes insanely easier if we consider the x and the y dimension separate. And the handout does say that you should do that. I believe somewhere right around here it says, somewhere it says that you should test the x and y's separately and then return the smaller of the two. Okay, that's very true. We should totally do x and y separately, because if we try to do this as one just big picture, like both at the same time, it's going to get really messy. So let's consider these separately. So I drew out two sets of images here, one for the x and one for the y's. So for now, let's just look at the x's, okay? And in fact, let's just look at this guy right here, okay? So if these two hitboxes, okay, we have a black and a gray hitbox here, and their points are labeled according to their color. So if these two hitboxes are overlapping in just the x dimension, we are only considering the x dimension here, then the distance that they're overlapping is d right here, which is, and I'll draw it out, d, which is equal to x2 minus x1. Okay? So think about that for a second. That's the distance that if these two hitboxes are overlapping in the x, it is distance d. Now, some of you might be thinking, like, what if it's not d? Like, what if this hitbox is actually on the left and this one's on the right? Well, we have another example for that, which is this down here. So this one is a little different because now d here is equal to x2 minus x1. Now, note that these two distances are different. Like, they are different because we start with this x2 here and then this x2 here. So these two are different, but they're two real possibilities that can happen if these two hitboxes are overlapping in the x. So what we need to do is we need to consider both of these cases. I'll name this one D1 and then this one D2. Distance 1 and distance 2. And we need to consider this distance and see which one is the smaller of the two. okay? Because now I'm drawing these hitboxes like this, but like I get that like some of you might be thinking like these like they might not be looking like this, and I would agree. 99% of the time they're not going to look exactly like this. But first of all, remember, I'm completely getting rid of the y dimension here because we're going to do that separately. That's over here. We're going to talk about that in a minute. But we're only talking about x's, so that they have to be squished to this one y here because we're not even considering y's. And on top of that, we're saying that if they are overlapping, this is how we'd calculate it. Okay? This is how we'd find that overlap. And we have to consider it two different ways. If one hitbox is on the left, and if the other hitbox is on the left. So we have to consider those two different ways, which leads to two different formulas here. This distance and this distance. And then we have to compare them and see which one's smaller of the two. So whichever one is smaller, we take that distance and we'll label that as the x distance. Okay, the x overlap. Okay, so let's just leave that at there for a second, okay? And let's say that that's going to be our x overlap. Now let's take a look at the y's, okay? Now, if we look at these images here, we might realize that, wait a second. This is the exact same image as this, literally just flipped on its side. Like, it's the exact same thing. But we have to consider it just slightly differently because, like, it's the y's, but it's the same exact logic here. Nothing really changes. So when we have our distance d, and we'll say this is d1 as well, this distance is going to be equal to y2 minus y1. Okay? And similarly here, this distance, d2, is going to be equal to y2 minus y1. And it's the same thing where we want to compare these distances. So we would see which one is smaller, and we would get the y distance. Or I guess, yeah, y distance. Okay. So we would compute these two values for both x and y, and find the smaller distance for each of them, okay? So now we have the value of the x overlap and the y overlap, and we know for a fact that it's the correct value because we have the minimum overlap, like we took the minimum here of both the x and the y's. Okay, and now we have one last step here, and it's actually not too hard. All that's left is now to compare our x and the y's. Oh boy, this is going to be big. Now we just have to compare the x and the y's and see which one is smaller for those two. And then at the end of the day, when all that's said and done, we just get our distance, aka, we'll do aka overlap. So, and this is our value. This is the method. It's a lot simpler when we break it down to x and y's separately, and then we compute the overlap. Like we're basically like boiling it down to the smallest pieces, and then taking something out of those two small pieces, taking something out of these two small pieces, comparing those together, and getting one final overlap or distance. And if they weren't overlapping at all, then the value here is going to be either 0 or some value less than 0, which that's fine. We just got to return that as well. If we look at the method specification on the actual doc here, if they're not overlapping at all, we should return 0 or a number less than 0, which that will naturally happen with our math logic here. So if you don't fully understand this picture, I would take a second and try to like really think about it. Maybe go through some test cases and follow through this logic of this picture, or draw your own pictures, and see if you could start to understand the examples here. Now, in this class, not many, like, we're not going to make so many methods that are like very math based, but this one's pretty important because, especially in game engines, collisions are a big deal, and we got to make sure we're calculating this stuff correctly. So that's how we do this, okay? I can't walk into too much specifics of how exactly to write this in code, But if you look at all of the variables we're using here, like we're using like all of my labels here, like you could translate these directly into code pretty much. If you know, obviously you can't have two variables named x1 and x1 here, but if you think about it, you know, it's technically like this is a black x1, this is a gray x1, so like take that as you will, however you want to, you know, label these things, but this is pretty much how it's going to work in code. So, and whenever I'm drawing these little arcs here, that means like take the minimum. So keep this in mind, you know, look at this for a bit, try to figure out if it makes sense to you. But the good news is once you complete that, the rest is pretty easy, or at least easier than that. So detect collision, this is extremely trivial after you complete a get overlap. All you need to do is, as it says here, you take your get overlap and basically just return if they're colliding. So I'm not going to give this one away too much because it's very simple. Just read it. You will be able to do this in not too long. Okay, trust me. But collide with dynamic object. Now this one's interesting because it sounds like just as hard as get overlap, but the good news is if you follow the same approach that we described for get overlap, you could almost pretty much copy and paste a lot of the same exact code for collide. Because collide, we're still looking for the smallest distance, okay? But here's the thing. We want, once we get our smallest distance, so it's literally going to be almost this exact same thing. But once we have our x and our y's, excuse me, we still want to find out which one is smaller, right? So whichever one is smaller, we want to, okay, so let's say the y overlap is smaller. So, okay, we take this y, and then we want to move the dynamic object away from the wall, because that's what we're doing in this method. We're writing collide in the wall class, okay? Collide with dynamic object in the wall class. And here, I'll just show you guys what it looks like, just so we're fully clear here. So we're in the wall class, and we're given a dynamic game object, right? But it's very similar because if we looked at the physics engine, the get overlap method, we're given two hitboxes, right? And we're going to return the overlap when it's all said and done. Now, in the wall class, we still have those two hitboxes. It's simply hitbox 1, or sorry, hitbox, we could even name it the same thing. Hitbox 1 is just equal to the wall's hitbox, okay? And it's very similar for hitbox 2. It's just the dynamic game object's hitbox. It's a very similar thing. We are still trying to get those distances, right? But whichever one is smaller, the x or y's, we want to move the dynamic game object that distance away from the wall. So that means that we have to just think about for a second, like, okay, am I going to move up? Like, if we're considering the y's, all that's left is like, okay, we have the y distance. Should I move the dynamic game object up the y distance or down the y distance? And I'll let you guys think about that a little bit. It's actually not too hard to solve this problem here, because we just got to see like where that dynamic game object is in relation to the wall. Like, let's say our wall is here at this location, because remember, locations are marked in the top left of the object. And let's say our dynamic game object, which I'm marking like this blue, is like right here in relation to the wall. So we already made it to this stage. Like, we already know we want to move the y distance, which we could also see from this visual. That's the smallest way to move out of here. And we just have to decide at this point, should we move up or down? Now, if you guys could probably tell me the answer just by looking at it. It's like, well, we should move down. This distance is like, it's way easier to move down. So think about why you're saying move down here, okay? It's going to be useful if you compare their locations to figure this one out. So think about that. I won't say the exact answer for this one because you could use pretty much the exact same logic from the get overlap up until this point, where then you have to decide. And again, if you have to consider those cases the same for the x's in this method. But overall, you have to do a lot less work if you did your get overlap correctly. So yeah, once you figure out, okay, I want to move down, then you just want to update the location of the dynamic game object to move down that distance. And then you want to turn off, basically, the velocity in the y for the dynamic game object, which, remember, we could modify those values directly. So if we said, like, okay, I want to move this dynamic game object, or I want to, let me find the exact wording from the doc here. Yeah, we want to set the velocity of the dynamic game object to 0. So, let me find this for a second. Where is that? Yeah, so right here. Its velocity in the x direction would be set to 0. If we moved it in the x, we just have to set the velocity in the x direction to 0. So remember, since we're dealing with objects, okay, which means like other object has a velocity directly. So .get velocity, then we have the option to either set x or set y, okay? And that will actually change the velocity of the dynamic game object. So keep those in mind, okay? That's the bulk. Like this, that is the coding part of, all the logical methods inside of the LO for this task. I get if you're overwhelmed, but it really will help you if you start drawing some pictures and taking time to think about this, because it is a tough task, and it will only get easier if you practice and fail and accept the failure. And also, it'll be easier if you write your tests. So, something I recommend while you're working on that stuff is to constantly be running this test task 1 class. So I'm going to run it, and I'm going to fail almost everything. Surprisingly, I passed some stuff. I don't know how. I didn't write anything. But these are all going to fail. But you'll know if you're doing them right without submitting to AutoLab if you're just running test task 1. And you should read these tests and see like why you're failing or passing. And by the way, once you pass all of them that say get overlap, you're really in the green, because let's see, there's 2 more really that need to pass, and like when you start writing it, it's probably not going to pass these 2. I think it's passing because I'm returning 0 all the time right now. But these 2, once all of the ones with get overlap in the name pass, then you're set on the get overlap method, and then you should start working on the tech collision and the collide. And then once all of those pass, you got it all set, and you should be able to run the game, and it should look like the example that I showed earlier. And then after all that's said and done, you have to write some tests for update object and the tech collision. You do not need to test get overlap and collide with dynamic object yourself. Those are all given to you. So that makes things a lot easier. We just have to write tests for update object, the tech collision. And so we want to write these tests in the test task 1 class. So the same class that all of these are in, we could just like move up top and write our own tests. So writing a test is very simple. We just write a method, call it like test. Let's see, this one is, we have to test update object. So we might make many tests for update object, but you could just write test update object, no parameters, but then we have to annotate this with the @test annotation. Now, you guys have probably already seen this in class, but that just marks this as a test for JUnit Java to be able to understand that. So then when we run this, we're going to see that test update object is now there, and it passed because we never have an assertion to fail this test. So if we did assert true, false, which is very weird, but hey, might as well, then we actually fail that test. Of course we did, because we literally just said assert that false is true. That doesn't make much sense. But yeah, so the testing part, the tests aren't too difficult for this one. They definitely do have some bulk, so they might take you guys some time, but this will give you a lot of good practice for testing, especially in the future tasks. So for update object, the doc is pretty explicit of how you actually should do this here. But just in the examples like we showed before, have some dynamic object, like a player, in a location, and call update object on it with some values, right? You want to first set the velocity of the player so that it's moving somewhere. And then you want to ensure that after calling update object, that player actually moved to where you expected it to move, right? So in our example before, how like if our player was here at 0, 0, and its velocity was 1 and delta time was 1, so dt equals 1, and then velocity is going to be equal to 1, 0, then we should expect it to move to be right here, which is at 1, 0, after calling update object. And we want to assert that is true. And again, if you're confused about this assertion stuff, try to read some of these tests. They're very good. They'll help you understand. Even go to test 0. That will help you understand assertions and stuff like that. Especially like these LO tests. It's really good stuff here. So, and don't worry if you don't understand everything, but if you're confused, I think it's worth taking a look. To make it all easier, we have a test utils class, which, so you're going to be working on testing utilities, of course, in this class. And like we have one called compare players, and that's something that we're going to have to make as well here. So there's specifications on this. Testing utilities will just make your tests easier to write. So you're going to want to make sure that if we ever tell you to make a testing utility, which is going to be like for this test, they're all usually going to be in test utils. If we tell you to make a testing utility, you should probably use that testing utility in your tests, because it's meant to be useful for you guys. So I get that this was a longer one and a mouthful, but that's pretty much the learning objective for game features. As you guys have probably seen, like compared to the problem set, a lot of concepts are similar, like with objects, like modifying data, methods, getters, setters, all that stuff. That's all useful information from the problem set, but you actually really apply this stuff in the game features LO. And I'm not going to discuss too much about the CU, because this is for the people that really want to go further in the course and get a great grade. And it has the same exact concepts, except we're doing a little more stuff here. Like we're making snake, which that's really fun. So I could probably show you guys what snake looks like. Just give me 1 second. Alright, so if you guys want to see what snake actually looks like, if we run this here, this is the complete version of snake. So you guys, if you've never played snake, every time you eat an apple, your tail grows a little longer. And yeah, you can see like it works just like snake. You guys could actually build this. This is the CU. It's really fun, and you guys should totally do it. But I'm not going to go too much over it, because this is the applying the stuff that you learned from the LO. Sorry, I'm locked in right now. Alright, I got it. Alright. But yeah, you guys should totally do the CU. That's how you get a great grade in this course. So you guys should totally do it. It's just the snake level class. That's all it is, and it's just a bunch of methods in there. So definitely, it's a little difficult. There's not as much math as, I don't even know if there's much math at all in here compared to the LO part. So yeah, you should absolutely do this, and I hope you guys have a great time completing this task. It's going to be so much fun. If you're confused about stuff, please go to office hours, ask questions on Piazza, but what you shouldn't do is start late on this LO. You really should start as soon as you can and try to get this done, and then absolutely try to get the CU done. So, alright, hope you guys found this somewhat useful at least, and I'll see you guys later.